Okay, welcome to lesson number 6, rounding sig figs in calculations. Our lesson objectives, we're going to round answers to proper significant figures in addition subtraction calculations, as well as do the same thing for the multiplication and division calculations. So students always ask, what do I round my answers to? So an answer can never be more precise than your least precise measurement. Another way to think about it is a chain is only as strong as its weakest link. So when we do calculations and we look at various measurements in the calculations, the least precise measurement is going to be dictating how precise our final calculation is. So let's look at adding, subtracting calculations first. So what do we round to when we add or subtract? We're going to round our answers to the least number of decimal places, meaning the least precise place value. So let's see an example. We have 3.75 ml. And we have 4.1 ml. 3.75 is precise all the way out to the 100th place, and 4.1 is only precise to the 10th place. So this is a more precise measurement. We don't know what's in this 100th place here because this measuring device, whatever it was not as precise. So our final answer can only be certain to the nearest 10th place. And so we're going to round our answer from our calculator to the nearest 10th place. And before we do so, we look at the next number that was cut off, and if it's 5 or greater, then we could round up. So this 5 is going to make this 8 round up to a 9, and our final answer is then 7.9 mLs. Again, going back to what I said, the least precise measurement here was to the nearest 10th place, and so our final answer is rounded to the 10th place. Let's see some more examples. 2.0 plus 5.61 equals 7.61. So let's look at the precision. This is precise to the 10th place. This is precise to the 100th place. So the least precise place value is going to be the 10th place. And so when we round this answer to the 10th, it's going to be 7.6. Next problem, 5.67 is precise to the 100th place, and 102.111 is precise to the 1000th place. So the least precise place value is the 100th place, and so that would be here on our answer, going 10th, 100th. And so this 1 is going to get cut off, and our final answer is going to be 107.78, again, to the nearest 100th place. The last one, 23, has no decimal point. This is not a very precise measurement, so it is actually only precise to this place value, which is the 1's place. This is precise to the 10th place, so our final answer can only be reported to the 1's place, which is the 4 here, and so the final answer then is going to be 34. Notice in all our numbers, when we do round, the answer is not changing, or the number is not changing dramatically. 7.61 goes to 7.6. 107.781, 107.78. So we're not dramatically changing the number. It's not going to be like 10.7. We're just saying that we don't know about this value here because our measurement here was not as precise. So let's check your understanding. Can you round answers to proper significant figures in our addition and subtraction calculations? Okay, now let's look at multiplication and division. So when we multiply or divide, there is a different set of rules. So in multiplication and division, we're going to round our answers to the least number of significant figures. So we have to count them up. So for example, if I want to multiply 13.91 times 23.3, I have to count my significant figures. So this first one here, 13.91, has 1, 2, 3, 4 significant figures. This has 1, 2, 3 significant figures. So the least number of significant figures is going to be 3 in this measurement here. So our final answer can only have 3 significant figures. So 1, 2, 3, which rounds to 324 grams. So let's see some more examples. 2.0 times 35.1. So this has 1, 2 significant figures. This has 1, 2, 3 significant figures. So the least number is going to be 2 sig fig. And so our answer gets rounded to 1, 2 sig fig. Notice I put a decimal point here. That's important. 70 without the decimal means that 0 is not significant, and it would only be 1 sig fig. This decimal point makes this 0 significant, and now I have 2 sig figs. The next problem, 5.11 is 3 sig figs. This is 4, 5 sig figs. So our final answer can only have 3 significant figures. So we go to our calculated answer here, and we want 3 sig fig. So our final answer is 504. That 0 is significant because it's trapped between those natural numbers. Division, same rule. So we have 72.1 has 3 sig figs. This has 4 sig figs. So our final answer can only have 3 sig figs. So I count those out. 1, 2, 3. So I'm going to cut it off right here. The 8 is going to make this 0 round up to a 1. And so the final answer then is 23.1. And last but not least, if we did a density calculation, same thing. It's a division problem. So 56 divided by 12.45. This has 2 sig figs. This has 4 sig figs. So the least number is going to be 2 significant figures. And so I'd get an answer of 4.5 grams per ml. So let's check your understanding. Can you round answers to proper significant figures in our multiplication and division calculations? At this point, you should be able to round answers to proper sig figs in addition and subtraction calculations, as well as round answers to proper sig figs in our multiplication and division calculations.